Hello class. Today we are gonna look at, well, hold on. We're not gonna learn anything new. Our objective is that you're going to be able to practice the skills of translating different parent functions and start reviewing for the test on Tuesday. So our agenda is you're gonna watch this video and you're gonna work through one problem per section. Now, I might do one, I might do two, I don't know. But then you're gonna work in groups. You may not work in groups. You may just work independently or just in pairs. Depends what Ms. Rousseau would like for you to do. And then you're going to work on the rest of the problems that you've gotten. So you should have gotten a little packet with 4 pages, well, 2 pages front and back. And your homework is to finish that packet of problems and check answers on Edline. So the answers will be posted. They will also be at the end of this video, which you can access on Edline yourselves later. Okay? So let's do it. The first section is asking us to write the function rule in the form g of x. So I could get started. It says write the rule in the form g of x equals. So I'm going to start with g of x equals. Okay? For the following transformations. So g is the graph of f. So this was our parent function, but it got translated 3 units to the right. Now I want to think about all the transformations we talked about the other day. We talked about what the negative does when it's out in front. We talked about what a does. Then there's a function, so it could be the absolute value, it could be a square root, it could be something squared. There's all sorts of things that could be right here, but this I'm just going to put the function. So there's some function, and then we have x minus h, right? That's our right and left shift, and this is our vertical shift, plus k. So we want to say, okay, well, if I'm moving 3 units to the right, that's going to be an inside operation, and we're doing it to our x, so it's the opposite. And we're going to say, well, let's see, to the right would be positive, so we're going to go x minus 3. But let's make sure we use the right parent function, so we're taking our square root, and we're going to have x minus 3. Let's double check it. To the right would be positive numbers, and we want to do the opposite of that. All right, so that would be the first one. Let's try this one as well. If I take g of x, if I say, okay, but g of x is f translated. Okay, we're doing 2 things here. We're reflecting it about the x-axis. We need to be really careful. This one right here is reflect over the x, and if there's one in here, then we're going to reflect over the y-axis. So we don't do many of these. You're going to do them in pre-calc, and we will do them when we're talking about exponential growth and decay, because that's a reflection over the y-axis. Do you see it? This is the y-axis. So that reflects over the y-axis a growth through decay. But there aren't too many of these that we do. But anyways, okay, so we're reflecting about the x-axis, the opposite of, and we're translating 5 units up. So that's my k value. So the opposite of 3x and plus k, right? Because we're going up 5. So that would be my equation for number 4. All right, the other ones I'm going to let you guys do. If you want to pause the video and try them, you're welcome to. If you want to just keep going, and we'll do a little bit from each section, then go back and do them all, that might be good too. So you decide what you'd like to do. All right, for each of the followings, it says state the parent function. Okay, so this is not the parent function. Our parent function was something else. So for each of these, I'm going to state, well, what is the most basic function that I started off with? If I didn't include all of these transformations, what parent function is that? Well, it looks like, oh, not g of x, sorry. Our starting function, which was different, our f of x function, was what? What do you see here? Yeah, the absolute value of x. All right, so that was our starting function. And then, so it says state the parent function, and then state each transformations sorry, it's each transformation that got me from F to G. Okay, then it says check it in your calculator to see if you're correct. So if you have your calculators with you, that'd be great for you to check them. All right, so let's check out what transformations happen. I'm going to start over here and say, well, it went down 9 units. So that is a vertical shift. Down 9 units. Will I accept just down 9 units? Well, maybe. But it's more thorough to write vertical shift down 9 units. So I would definitely encourage you to put as much information in there as possible. So vertical shift is up or down. This +6 is telling me it's a horizontal shift, or horizontal translation. Horizontal. Oops. And in this case, we're going 6 units. And I need to think about this because I'm on the inside, not to the right because it's positive. I want to go the opposite to the left. So be careful when it's on the inside. All right, then we have 2 more out here. Some of you might see that as 1, but it's really 2. So there's a stretch by a factor of 2. By a factor of. That's what BAFO is. By a factor of 2. Stretched by a factor of 2. And the negative is a reflection. So we need to do that as a separate thing. Reflection over which axis? Reflection over, if it's out in front, it's going to be over the x-axis. Good. Reflection over the x-axis. All right, so that would be that one. This has 4 transformations. This one only has 2. This one has 2, and that one has 1. Man, I did the most difficult one with you. All right, I didn't mean to do that. I'll let you guys do the other 3, and you can check your answers later. All right, let's try a graphing. Which one shall we do? Let's try this one. D looks good. Let's try D together. All right, so we learned the other day, actually, let's see, Wednesday. I'm actually filming this on Wednesday. You're going to learn this today. Well, now I'm confusing you. Okay, never mind. You will have learned this on Wednesday. So we want to start off with our parent function values. And our parent function would be the square root of x. So to start off our x values, we have to decide, well, which x values do we want to use? Can I put a negative number in here? Would I want to start with -2 or -4? You can't, right? When you have a square root of a number, it needs to be 0 or greater if it's going to be a real number. So we definitely want to start with a 0 because we want all non-negative numbers. So square root of 0 is 0. Let's try 1. Can I find the square root of 1? You could on your calculators plug it in, but what times what equals 1? Well, 1. 1 times 1, right? Okay, do I want to do 2? I could. Square root of 2. How many guys want to use that? Do you know what the square root of 2 is? Oh, I don't exactly know what it is. I know it's a decimal. I know it's somewhere between 1 and 2. It's 1 point something something something. But it's not a nice number to have to be plotting and doing transformations to. So I'd rather use whole numbers that I can find for my input output. So what's the next number that would give you a nice square root? Yeah. I was going to say yes, Jamie, because I imagine Jamie's going to say the answer. All right. The square root of 4 is 2, and the next nicest square root would be 9. So square root of 9 is 3. I mean, the next perfect square would be 9. All right. So these are often values we use for the square root function. Hopefully you're already kind of feeling that. Now we want to do transformations. We want to say, well, what happened? Because I started off with just the square root, but then 3 things happened, right? We went right 1, we went up 3, and we reflected over the x. So if I reflect over the x, that's affecting if I started like this and then I reflected over the x, what values is that changing? Is it changing my x values, or is it affecting my y values? Aha! If these reflect over, it actually is affecting the y. So this affects the y, this affects the x in the opposite direction, and this affects the y, right? Up and down is going to affect my y-axis. Oh, speaking of that, let's label our axes. That's very important. Okay, so let's go ahead and make our chart. So here we need to do multiply before we do add. So we're going to find the opposite of y. And the opposite of 0 is just 0. Don't say negative 0. It sounds funny. It is not. There is no opposite of 0. The opposite of 2 is negative 2. Opposite of 3, negative 3. So sometimes students say, well, why don't I have to take the square root? Well, you already did. Right here, you took the square root. Then you made it the opposite. And we have one more thing to do. So we took the opposite of y and we did what? We went up 3. So I take these values now and I add 3 to them. 3 minus 1, 2. 3 minus 2, 3 minus 3. All right, these are my new y values. Let's go find out our x values. So here we have x minus 1. We need to do x plus 1. Biggest confusion or mistake that I see in the past is when students don't remember that that has to be the opposite. I think I probably said that a million times. I'm probably going to say it a million more. And if you, there's a reason I'm saying it. All right, so 0 plus 1, 1. 1 plus 1, 2. So I'm taking my x values and I'm adding 1 to them. 4 plus 1, 5. 9 plus 1, 10. All right, so these are my x values. These are my y values. So 1 is related to 3. If I input a 1, I output a 3. And we could actually double check that. If I plug in a 1 here, 1 minus 1 is 0. Square root of 0 is 0. The opposite of 0 is 0 plus 3. So this is my input. This is my output. Now we have 2, 2, 5, 1, and 10, 0. So these values are the ones I want to plot. So 1, 1, 2, 3, 2, 2, 5, 1, and 10, 0. So now I want to connect them. Now I have to know, I have to know what my parent function looks like. Do I put an arrow here? Do I put it, where does my arrow go? If I don't know what my parent function should look like, then I'm going to have some trouble. So the square root of x, you need to memorize what that shape looks like, or at least be able to create it with those parent values right here. So let's just double check. I took my parent function, which was like right here, and I shifted it up 3, right 1, and it reflected over the x-axis. Looks pretty good. All right, so I'm going to let you do the other 4, and you can check your answers at the end of the video. Now it's asking, well, what if I had to write the equation for this? So let's see. Okay, here we have a shift 1, 2, 3 units down. So that feels like it's going to be on the outside, minus 3. We have to think about what is our parent function. Now, do I need to do this? Is there any shift right or left? Our vertex is still there on the axis. So there actually isn't any right or left shift, and I don't need these parentheses. I'm just going to make up a letter because it doesn't tell me what to use. So I don't really need parentheses in this case, but I always start it like that in case there's a right or left shift. So I'm just going to simplify this and say, okay, f of x equals x squared minus 3. So my function of x squared, my parabola, got shifted down 3 units. Now I want to check my dimensions. I'm going to go over 1, up 1, because 1 squared is 1, and 2 squared is 4, and 3 squared is 9. So as long as my dimensions are the same, then I didn't have any stretch or compress. And I want to check and make sure it's opening upwards, so it's positive. If it was opening this way, I would need a negative out in front, because it reflected over the x. Whew, I'm talking a lot. I'm sorry, guys. Okay, I will let you get to work. So that would be my answer. Right here is the equation of that. And then on this last page, it's just a couple of kind of refreshers. This is a review of lessons that we've talked about, talking about domain and range. And then state whether each relation is a function. It's just yes or no. State the domain and range for each, and evaluate the function for that and that. So basically plug in 1, plug in -1, see what you get. Okay? And then the next page, we're doing some add, subtract, multiply, divide, composition. That's composition. Be careful. Or did they mean for that? Oh my goodness. I wonder if this is supposed to be multiply, because it sure looks odd that they don't have any multiply in there. Okay, well, we'll check it out when we see the answers. Oh, I'm already on that page. Okay. Find the inverse of each function. So here we're, x and y, switch places, right? And then x and y switch places and solve. I believe that's a negative right there. Okay. So you can try those. I'm about to go ahead and show you all the answers. So I'm just going to go through them quickly, and you can just pause the video on each page if you want to check them, or if you want to turn the video off. Take time, practice, and then go back and check the answers. That'd be great. Okay. All right. Thank you for watching. Have a wonderful Friday and a wonderful weekend. Make good choices. Be safe. All right. I'll see you guys next Tuesday. All right. Work hard. Here we go. That's an equal sign. That looks like a dot. All right. So these are answers for that first section. Pause it if you want to stay on here. Answers for the second section. Answers for the third section. Notice my shapes: parabola, square root, and absolute value. It's very important that you know what those parent functions look like. And these ones, we did this one together. Yay, we got it right. All right. Next page. Also, be really careful of this. I'm not a fan of this. Like, where it doesn't quite, I can't quite tell if that 4 is underneath or outside, and it's like, well, I'm not really sure, so I'm just gonna put like halfway, and then I can argue if it's in or out. If it's ambiguous like that, ambiguous meaning I can't tell, I will not give you credit. I will assume that this is questionable. So make it very clear that it's either inside the parentheses, sorry, not parentheses, the radical, or outside. Make sure if it's outside, it's very clear that it's outside. Okay? All right. Not that any of you would ever be ambiguous. All right. Okay. So the answers, let's see. We done this one yet? Not yet. Absolute value, shifted left 2. Remember, so we do the opposite here. All right. This answers are a little harder to see. Maybe I'll highlight them. I hope this video isn't getting horribly long. Yes, yes, no, no. State the domain and range of each function. Oh, okay. Well, the domain would be all the x values. And the range, it would just be a roster. And then the range would be the y values. Evaluate each function for, okay, so if I evaluate it for 1, I get that. -1, I get that. 1, -1. Oh, that's interesting. 1, -1, and 1, -1. All right. On this page, let's see, we were wondering about 31. 31, is it a composition or a multiplication? F of G, plug G into F. No, it is a composition, I believe. No, it's not. Okay, it looks like we are multiplying. Yeah, this is supposed to, so this was a typo. That is supposed to be a multiplication, not a composition. So I apologize for that not clearness. These are a little bit more complex than we've been working with, but it's the same concept. Take x over 2 minus 5 is not allowed to equal 0. Add 5 times 2, and x is not allowed to equal 10. Okay, so you need to state that restriction, and notice this division and the restriction are both part of the answer. Okay? All right, these guys have answers down here. These are compositions. All right, next page. Find the inverse of each function. Oh, here are your answers. 41, 42, 43, and 44. Is that it? That's it. We're done. All right. Well, thank you guys for watching. All right. Have a wonderful weekend. I will see you on Tuesday.